If you're like me, you've seen wharfs and ports and been fascinated by the huge ships, cranes, trucks, and most of all, by the containers stacked like building blocks. But what are the processes of container ports like this? How are containers unloaded? Where do they go? And what happens next? We're going to find out if containerization is as orderly as it seems, or if there is some chaos in these neatly stacked rows, and what opportunity and challenges automation has brought to the shipping industry. Containerization has changed the world. Previously, ships would hold multiple smaller loads, all jumbled together into a cargo hold. Now the sorting of cargo into containers is done before the cargo is loaded. This allows ships to have greater efficiency when loading and unloading cargo. But it has also brought new challenges for organisation, as gigantic ships dock in large ports and need to unload hundreds or thousands of containers at a time. Container terminals are hubs of intermodal transport. That means that containers are switching modes of transport from a ship, which travels on the sea, to either road or rail. Containers can also be moved by air, but this is not usually the focus of container ports. Switching modes of transport is not quite as simple as loading a cargo container from a ship onto a truck. Multiple steps and organisational challenges are involved before the container rolls out of the freight yard. First, the container must be unloaded from the ship. This is achieved with huge gantry cranes that are able to lift the several tons of container and its cargo. Cranes can be hinged to allow for passage of large ships beneath, or can be fixed to reduce airspace being taken up. Cranes connect to containers by their corner fittings, which, like most other parts of a container, are standardised throughout the world by the International Organization for Standardization. Another international standard is the unique identifier number, which helps to keep track of each container. The containers are typically loaded onto terminal tractors. These funny-looking trucks are meant for short-distance haulage, in order to get the container from beside the ship into the storage yard, where the containers wait to be picked up by a truck or a train. In order to move containers around a storage yard and onto trucks and trains, there are several options for machinery. Two of the most interesting are reach stackers and rubber tyre gantries. Rubber tyre gantries have wheels and are cranes that are able to fully straddle containers. Larger versions may run on tracks rather than tyres and can straddle multiple rows of containers. Reach stackers have a long arm that can easily be used to stack containers several rows deep, or to negotiate them onto semi-trailers and rail cars. Every step of the process described so far has the capacity to be fully or semi-automated. And in fact, at some of the terminals at the port of Rotterdam in the Netherlands, they all are, at least partially. At this port, a crane operator remotely operates the gantry crane via computer software that unloads containers from a ship. The container is loaded onto a fully automated terminal truck, which drives it to the storage area to be unloaded by an automated stacker crane. This is one area where logical planning augmented by computers can provide a huge benefit. Knowing exactly what date and time a container needs to be picked up, a computer can plan the most efficient way to stack containers. This ensures the container isn't buried too deep in the stacks when it comes time to leave the yard, reducing the number of operations required to access the required container. There are still some storage yards around the world that use a paper-based tracking system. For some of these yards, this means that containers are simply stacked according to when they are brought into the storage yard, so that when the time comes to take them out again, they might be at the bottom of a stack of containers. Like many other industries, computerized automation provides some unique benefits over human operation, such as accuracy of repetitive tasks and logical planning of efficient processes, until something goes wrong and many hours are spent trying to troubleshoot and fix the issue. For now at least, humans maintain the advantage of adaptability over fully automated machines. Automating a container port is very expensive, but ports implementing this technology hope to gain benefits such as increased productivity and increased safety. Of course, even at ports where automation exists, humans are still employed to oversee and maintain the machines and rectify problems as they arise. As automation continues, concerns about job losses are always on the forefront of debate. There is also the real cost to society, with a smaller income tax revenue stream to fund things like roads and rail, the very things the transport industry relies on. Ideas have been put forward for a robot tax to help subsidise this loss. However these problems are dealt with in the future, it's clear for now that the inevitable march of the machines will continue. Perhaps the solution lies balanced somewhere in the middle, with human operators and overseers able to quickly adapt to unforeseen problems, but with machines performing dangerous tasks for us, and with organisational systems augmented by computerised calculations. Thanks for watching this video about how a shipping container port works. Be sure to subscribe to the channel for more videos, leave me a thumb, and let me know what you thought of the video in the comments. Thanks for watching.